In this video, we're going to look at solving absolute value inequalities, and we're going to break this objective up into two videos just so they're not too long. But the general method that we're going to look at in this course for solving inequalities is we're going to treat them like equations. So we'll first learn how to solve the equation, which is what we talked about in the last video. And then once we get our answers for the equation, we're going to use test values on a number line along with that answer that we got to determine which values are going to make the original inequality true. So example 2, we're going to solve the absolute value of x minus 1 is greater than or equal to 3. So let's treat it as if it's absolute value of x minus 1 equals 3, which we know from the last video we're going to get two different cases. One where x minus 1 equals 3, and one where x minus 1 equals negative 3. So solving each one, first one we get x equals 4, the second we get x equals negative 2. Now we're going to put those numbers on a number line and make sure that you're putting them in the right order on the number line. So even though we solved, got a 4 as our first answer, 4 is not going to be the first number. 4 is always going to be to the right of negative 2. So now let's plug 4 into the original problem. 4 minus 1 is 3. The absolute value of 3 is greater than or equal to 3. So 4, we use a closed circle because it's true. And then negative 2 minus 1 is negative 3. The absolute value of negative 3 is 3. And 3 is greater than or equal to 3. So this one's also true. So close circle at negative 2. And then we can test out values, we can pick values in each of these intervals, less than negative 2, between negative 2 and 4, and greater than 4, and test them out in the original inequality and see which ones make it true. So if we pick a number that's less than negative 2, like negative 10 minus 1 is negative 11, the absolute value of that is 11, and 11 is greater than or equal to 3. So we would definitely include the values on our number line that are less than negative 2. Between negative 2 and 4, we can try 0. 0 minus 1 is negative 1. The absolute value of negative 1 is 1. 1 is not greater than or equal to 3, so we would not shade anything between negative 2 and 4. And then pick a value bigger than 4, like 10. 10 minus 1 is 9. Absolute value of 9 is 9, and 9 is greater than or equal to 3. So our final graph would look like this. We'd shade to the left of negative 2, and then shade to the right of 4. And so writing each of these in interval notation, less than or equal to negative 2 is parenthesis, negative infinity, and then a bracket after negative 2. And then we're going to unite that interval with the interval greater than or equal to 4. So bracket 4 to infinity with parentheses. So here's our final answer in interval notation. Now the graph of the graphical interpretation of that answer, here in blue we have the absolute value of x minus 1, and then here in red we have the line y equals 3. And here's our intersection points, x equals negative 2 and x equals 4. And what the graphical interpretation of this inequality is where is the graph of the left-hand side at or above the graph of the right-hand side? So the blue graph is at or above the red graph for values of x that are less than or equal to negative 2, and for values of x that are greater than or equal to 4. So in terms of graphing, we can find the intersection points. That'll give us these two numbers. And then from a visual perspective, if we have greater than, it's where the graph on the left is greater than the graph on the right. So if we have something like absolute value of x minus 1 and y equals 3, for greater than, it's where is the graph of f of x above the graph of g of x. For greater than or equal to, it's at or above. So the equal to part just means it can equal it. For less than, it's where is the graph of f of x below the graph of g of x. So where is the graph on the left below the graph on the right. And then for less than or equal to, it's where is the graph on the left at or below the graph on the right. So just as a way, you can also use that to help you out, especially when checking your answers. So part B, we have 4 minus 3 times the absolute value of 2x plus 1 is greater than negative 2. Well, first let's make it equal to negative 2, and we'll solve it from here. Now in this problem, the absolute value expression is not by itself. It's got this 4 that is being added and a negative 3 that's being multiplied by. So we got to clean it up a little bit on the left-hand side. First up, we subtract 4 from both sides, and we get negative 2 minus 4 is negative 6. So we have negative 3 times absolute value of 2x plus 1 equals negative 6. Then divide both sides by negative 3. That'll get our absolute value by itself. So we have the absolute value of 2x plus 1 equals negative 6 divided by negative 3 is 2. So now that we have absolute value bars by themselves on the left, now you can break this up into two cases. One where 2x plus 1 equals 2, and another one where 2x plus 1 equals negative 2. So solving each one of these, we get x equals 1 half and x equals negative 3 halves. And on our number line, if we test out the values a half and negative 3 halves, because this is a greater than symbol, we have to use open circles at negative 3 halves and positive 1 half because it's greater than, not greater than or equal to. And then the values that'll work will be the ones in between the negative 3 halves and the positive 1 half. So our interval answer for this is negative 3 halves to a half with parentheses because it cannot equal those values. The graphical interpretation of this is the graph in blue is the one on the left. The graph in red is the graph on the right. So where's the graph in blue above the graph on the right? It's above the graph in this triangle part here. So here's our negative 3 halves. Here's our 1 half. Anything between negative 3 halves and positive 1 half will work with, again, we can't equal them, so don't include these intersection points. All right, that about does it for this video. Thanks for watching, and I'll see you next time.